Prometheus is a reconfigurable drone designed and developed to explore underground voids, mines, and extreme environments. It is expected to do that safely and autonomously. The drone is also expected to be deployed and retrieved through a 150mm borehole. Now, in comparison to traditional surveying approaches, the Prometheus drone offers huge cost savings and reduces risk to human life significantly. 2020 has been a remarkably challenging year for us all, but it has marked an important milestone for the project. Through a set of field trials and tests at the historic lead mines in Snail Beach, UK, the team have demonstrated various capabilities, but also this has proven to be a huge opportunity for us to validate some of the assumptions we've made. These tests included confined space flights, imaging and mapping in pitch dark environments using Headlight AI's Dragonfly scanner, and planning algorithms that made use of artificial intelligence to achieve and improve navigation of the drone. This video presents some of our findings, but also celebrates our success so far, so I hope you enjoy.
The University of Bristol is working closely with other partners in the project to integrate planning, sensing and flight control software. Alongside this, we're also working on part of the deployment and retrieval mechanism to allow us to operate in boreholes. As part of this work, we've put together this prototype vehicle. This vehicle has the same electronics, powertrain and the same layout as the final vehicle. Using this vehicle, along with the flying green here at the Bristol Robotics Lab, we're able to test the software in a controlled environment before we then take it out into the field. Our field trial focused on three main things. Firstly, capturing some data with the Dragonfly sensor. Secondly, looking at how the motor vehicles performed in those confined spaces underground. And thirdly, looking at how our radios performed in an underground environment. As part of our first field trials, this vehicle carried a prototype of the Dragonfly sensor. This allowed us to capture our first in-situ, in-flight data. Alongside that test, we were also carrying out some more basic flight tests to help us understand the effects of the complex flows that occur in confined spaces and their effect on multi-rotor performance. Alongside that, we're also looking at how our radios degrade as we start to go around corners and lose line of sight. Both of those results turned out pretty much as we expected. So yes, there are some performance impacts of flying multi-rotor in a confined space, but we found that the most significant effects only really occur when you're within 1 to 2 rotor diameters of a wall or ceiling. So that really just highlights why this vehicle has been designed from the start to carry all of the hardware it needs to be able to operate completely autonomously.
As part of Prometheus, we're developing a lightweight 3D sensing solution which generates a 360-degree 3D point cloud. This point cloud will be used for SLAM and navigation when in the confined spaces. Snail Beach was the first time this sensor was deployed on a drone in a representative environment. The data gathered at Snail Beach will be used to further fine-tune the SLAM algorithm, mapping algorithm, as well as the data collection algorithm that we're developing at Headlight AI.
We are working on the exploration tasks in confined spaces. These tasks become highly challenging due to constraints imposed by the nature of the environment. For example, there are dead-end branches and bifurcations. So to deal with these challenges, we develop advanced exploration and navigation planning at Royal Holloway. Also, recently we tested our planner with the Snail Beach mine data. As you can see in this problem, the task is the robot needs to explore the environment and get back home within 20 minutes. As we can see here, the robot is able to navigate autonomously to unknown regions and map the areas.
The University of Manchester is responsible for the design of the reconfigurable prototype drone, as well as the development of the deployment mechanism, which is the thing that places the robot into the voids. The objectives of the test was to understand what it was like trying to operate one of these vehicles in a mine environment, looking at the wireless communications and how they degrade as you go further into the mine, as well as other operational constraints such as takeoff and landing points, as well as what it's like trying to fly these vehicles in the rough terrain of the mine, so near the walls, near the ceilings, and the effect that that has on the vehicle. The telemetry link performed better than expected. It was able to maintain a stable link around multiple corners through solid rock.
So I hope you've enjoyed and are excited by what you've seen so far. 2021 is equally an exciting year for us. we've lined up integration test 3 and integration test 4. We're going to further demonstrate the drone capabilities in a real mine-like environment. So please stay tuned for more videos, and for further information please do visit our website.